Hi, welcome to the third webinar in 12D's 2017 training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D Model software. The aim of these webinars is to upskill 12D Model users and broaden their understanding of the capabilities of 12D Model. We run these webinars regularly and record them for posting through our website and on YouTube. 17 webinars from our training series, as well as 19 webinars from our Industry Solutions series, are available on YouTube if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Please note that today's presentation includes a handout you can download at any time during the next hour. Today's webinar, 12D Track Part 2, will be presented by Alistair McCrudden, who first started using 12D Model, or rather 4D Model as it was known then, in 1996. From 1997, he ran 12D training courses through a reseller, and then in 1998 he commenced contracting directly to 12D, and he's run our WA support and training ever since. Alistair's vast rail experience includes heavy rail in northwestern Australia and Africa, port facilities relating to rail and ports interface, and passenger rail. He is loath to be called an expert in this topic, but we certainly think that the term is apt. This webinar continues on from 12D Track Part 1, which was held in January. Extensive railway tools in 12D Track allow the rail designer to quickly and easily design their projects. These options are built onto the existing 3D modeling and design tools available in 12D Model. In this session, we'll explore Chainage Equalities, developing and editing Cant, applying the Cant and plotting the rails with associated Cant, and developing and plotting the structure gauge. Over to you, Alistair.
Thanks, Lisa. In this session, we're going to be looking at chainage equalities. Now, chainage equalities enable us to put a secondary set of chainages along a track. Chainage equalities are fairly common on track detailing. There may be many reasons for having them in there. Common ones would be that you have slightly realigned a track and you want to tie back your chainages to what you had before, as all the signaling and signages associated with those. Alternatively, you may have a parallel track going in and you want to have matching chainages along that parallel piece of track.
It's important to understand that the chainage equalities give you, if you like, a second tier of chainages along the string. In other words, you will always have the raw or real chainage of the string embedded in the string, and all that we're doing by putting chainage equations or equalities onto that string is to fool the display into showing us different chainages along that string. This of course then means that we will have to use a couple of tools later on to see exactly which one is the raw chainage and which one is the equality chainage.
The first thing we need to understand is that by default with an alignment string, chainage equalities are not switched on, so we need to make sure that we enable them. To do so, we're going to come in here. I'm going to go and edit the super alignment string, then coming down to the icon for the parts editors. If we just hold our mouse button down on that, come down to the fourth icon down, which is the chainage equalities editor, when we come into there, you'll see at the moment we aren't able to do anything. If we try and pick or add anything like that, nothing will happen. So what we need to do is we need to come across to the Properties tab, come down to the Equality option in the Advanced mode, and tick on Use Chainage Equalities, set that, and finish. Now if we go back to that fourth icon down, come down to the Chainage Equalities tab, you'll see now we have an icon in here which says equalities, and we can go and pick on that, insert a new equality. As far as the types of equalities go, there are 4 different types. So the first option we have is a k-post by coordinate, where we will actually go and pick a coordinate. For instance, we'll pick this known k-post here. It'll choose that coordinate and set the quality changes relative to that.
So we'll choose the k-post coordinate. First thing we're going to do is we're going to come in here and we'll give it a prefix, which the name will be 4km, which, as I was starting to say, will be a prefix in front of the numeric value. We'll then come down and pick on the XY button here, select the insertion point of that k-post peg, and we'll hit set. Now it's important to realize that anytime you set any Chainage equality, you must do a redraw to be able to see the text coming in. So you can see over here we've got 4 kilometers 000, and over here it's 4,000.00 equals 4 kilometers. Over to the right here you can see we've got 4 kilometers 100. The next type of equality that we're going to put in is going to be an internal equality. So what we're going to do here is we'll go and add an equality by picking on the insert button. We'll go and choose our type. We'll get the internal equality. We're going to go and do a right mouse button pick on the measure button here. We're going to go and get string from point. We'll come out and get the chainage of our super alignment string. We're then going to wander along until we get to the marker that's the 4.5 kilometer post. So that'll be this one over here. And then what we're going to do is we will go and pick the post itself, the insertion point of that post. That gives us the chainage up here. What we're going to do is we're going to knock out the 4,000, so it just comes down to the 497, and then that will equate to our new 500. When we hit set, remember we need to do a redraw, and there's our new equality there, showing us that we've got 4 kilometer, which is 4 kilometers 497.311 is equivalent to the 4 kilometers 500 meters. We're again going to go and put in, for our third one, a k-post coordinate. So we'll go to insert. We'll choose our type as a k-post coordinate. We'll put the name in here again, which remember is your prefix to the numeric. That's going to be 5km. We're then going to go and pick on the coordinate for the 5 kilometer post. So we'll pick on the XY button here. We'll zoom along until we get the 5 kilometer post, which is in here. We pick the insertion point of that, hit set. Again, our redraw gives us our new chainage along there, and that's showing us that we've got 4 kilometers 1000.747 is now equivalent to the 5 kilometer mark. For the fourth equality, what we're actually going to do is we're going to initially start off with a k-post, but then we'll actually change it to an internal equality. The reason we're going to do that is we'll let 12D calculate the true chainage for us at a known point, and then we can easily override that. So we'll add our new option. Again, we pick on the insert. To start with, as I said, this is going to be a k-post coordinate. We'll put X in here for the moment, and then what we're going to do is we're going to go and find the surveyed 5.5 kilometer post. So again, we're picking on the XY here. We'll come along here until we find the 5.5 kilometer post. Now again, it doesn't matter whether we pick it on one side or the other, they should be exactly the same chainage back to the string there. When we go and hit set on that, it shows us that the post here is at 499.609. So what we're going to do now is change this option from being a K-post coordinate. We're going to make that an internal equality. The before is going to be the 499.609, and the after is going to be 500, because that's obviously the half kilometer mark there. We go and hit set on that, and a redraw will now show us that 5 kilometers, 499 point blah blah blah, is equivalent to 5 kilometers, 500. Now one last thing on that one before we move and put the next equality in. You'll notice that when I first started that off and we were using a K-post coordinate, I put an X in there. The reason for that is because if you don't have a name, which of course, as we said, becomes a prefix for the numeric value, in the K-post chainage or K-post coordinate, when you go and hit set, without that name in there, you won't actually see your text update. So there's a little trap there you need to be aware of, that you do need to have a name in there. I put X in purely as it was going to be replaced by our known chainage after we've done that. Okay, so we'll now go and put one last chainage equality in here, and this is actually going to occur down around about the 6 kilometer mark. And what's happening there is that by the time we get to 6 kilometers with our amended alignment, we'll be back on the original chainages of that railway line. So we'll go and pick on our insert. We'll put a new one in there, which is going to be a K-post coordinate again. We'll put the name in there of 6km, and then we're going to go and pick, using the XY button here, we'll go along and find the 6 kilometer post on the railway line. So here it is. We pick the 6 kilometer post, hit set. When we do our redraw over here, we've now set our kilometers back to the original reference chainage along there. There is one other type of equality which I haven't shown here, and that is the K-post relative. Now the K-post relative defines a K-post chainage relative to a previous K-post or internal equality. So it's not one that's all that often used, but it basically gives a small override within an area that's already been given some equalities. First of all, as far as the labeling goes, a couple of little things that are happening in here. When we come in and we've put in a chainage equality, you'll notice that on the points where I've actually made some form of equality, I end up with both yellow and white text. What that's saying is the chainage along the string, this is still an equality chainage, is 4,000 meters, which is your 4 kilometers, and this then is saying that the equation that occurs there is 4,000 meters is now equivalent to 4 kilometers. So the yellow and white text denote that there is actually a change of chainage there. Again, the colors of yellow and white are purely based on the super alignment style that you've got at the time. You can change the colors of those, the size of the text and the font, etc. We come along here, then we've just got the yellow text, so that's saying that the chainage at that point using the chainage equalities is 4 kilometers and 50 meters. Because there's no white text in there, it means that there's no change to the chainage by having an equality in there. So that'll happen all the way along. Whenever we get the extra bit of text in there, the white one is saying that's the point where an equality has been placed. So we'll finish on that panel for the moment, and then I just wanted to run through two tools that we'd have in here, which would be to check chainages and chainage equalities on the track toolbar. I'll start with the chainage from an equality. When I go and pick on this, I go and select my super alignment. I'll actually just use the same point for both of these options, so I'll use a point snap to that point there, and when I accept that, what that does is it comes up and tells me that I am using a chainage from an equality here. The K-post name is 5 kilometers, the chainage from that point is 270, etc. Down here it actually gives me the natural chainage, so that is, if you like, the real or raw chainage at that point, and then it's telling me how much further on from that point that occurs. So that was the first of those two options. That was this one here where we had the chainage from an equality. The other one we've got is equality from a chainage, which gives us a very similar result. What I'm going to do is go and pick the same string at the same point, so we can compare both these panels. And there it is in there. This one now tells us that the natural chainage is at 5268.561, and grayed out below that it actually gives us the K-post name and the equality variation that's occurred from that point. So those two there are both options that you will use from time to time, and you can also get those from strings, super alignment tools, and there they live down there, so we can go and get them from the pull down menu. In this session we're going to be looking at calculating the cant, and once the cant has been calculated we'll look at plotting it and all the associated outputs. Now there's two places that we can get the cant option from, either from the pull down menu, which we've got pinned over here. We've got the calculate cant option showing here. Alternatively, we can come to our rail toolbar sitting up here, go and choose the calculate cant panel from there. So I'm just going to pull the panel over here out of the way. We've got a series of tabs on here as per a lot of the 12D panels. If we go to the design limits in here, this is, if you like, a general overall set of controls for what might occur on any given rail line. What we'll be doing is that we're actually going to be setting a few variations to this which will be put in for this particular string. So we come back onto the Cant design here. What we'll do is we'll set the design speed of 60 kilometers per hour. We'll set the track gauge to 1067 millimeters. We'll then pick on the large button here, go and pick the alignment string and accept it. Now, because I've run this in the past, it's coming up and saying that there's already some data in there. Do I want to save it? Yes, no, whatever. I'll just say yes. Whether you've run it in the past or not, as soon as you've gone and picked the rail alignment tab here, then you will get feedback on the geometry of the selected alignment string. Now, we can then come across here, and if we go and pick on any one of these fields in here, any of these lines, that then gives us information on the right hand side, which is the station data portion of the panel, and then we can see the cant that's been applied, the element itself, what have you, and as we move down through each of those options, it gives us the settings for those. We'll come back and play with those a little bit later on. We'll go across now to the Cant graph. Inside the Cant graph we get a little graph down the bottom here. We've got a legend in there which is showing us the equalities and what have you, the deficiencies, etc., etc. Inside the graph here we can move around in there by using these tools up here. Similar to the other track tools, they work slightly differently from some of the others inside 12D. Obviously the fit will make the data fit to the particular view. I can go and zoom a window, so I'll start with the zoom window, pick on that button there, select the first part of my window, drag out, select the second part of my window, and instantly that updates for me inside that little view. Now I can go and use the pan option, so I'll pick on the pan button. Again, works slightly differently from pan in overall 12D. One mouse button, click and release. then drag the cursor down to where you want it to go, pick and release again, finishes that pan. Pick again and release, drag, pick and release, etc. As we said, fit the data to there. If I then want to go and zoom the scales either in the X or the Y, I can pick on this button here. What I then do is pick a point that I want to scale it around, and then if I drag my mouse horizontally, it stretches in the horizontal direction. If I pick and move my mouse in the vertical direction, then it changes the vertical extent there. So I can do both of them at once by moving them diagonally and so on. So the horizontal is changed by left to right movement, the vertical exaggeration is changed by top to bottom movement, or as I said, diagonally drag it out wherever you want to go, etc., until you're happy with what you've got. I'll go back and do a fit on that. The next thing is that's got rid of all of these apart from the plot option here. So if I go and pick on that, this is now going to go and plot the graph to a model for me. So I need to be careful that I don't overwrite any other models that I may have created from these plotting options in the past. So in here I'm going to go and say this is Cant graph, and then of course under normal circumstances on a real job where you have more than one line, you would come to the end here and you'd go and give the name of that particular string that we're working on here. Go and do a plot on that. I can then go to another view here, go and add my new model in here, which is called plot Cant graph XXX. There is my graph plotted. You'll see it's taken everything that was on the screen. The only part that is missing is the legend. That is not sent out with it, but everything else is in there and it can be plotted in a normal manner. Okay, so let's go back to our alignment here and we'll have a look at the Cant graph in a bit more detail. In the top portion of this, you can see that we've got all of our feedback on what's going on, and at any point if I hover my mouse over a field in the top half of that panel, just above the OK, Apply, Finish, etc., there is a yellow text in there at the moment which is saying Chainage 4000. We come across to the next field. This has got a red box around it. That is saying that I'm not matching my design criteria for this particular portion. And if I hover my mouse over that, it's then saying the radius is 300 point something or other and is less than the required minimum of 400 meters. Now we can change that, because if I go back to my design limits tab up here, what I can do there is I can come in and change my minimum radius for this particular design, and obviously these things are always going to change with every single rail track that you do, your upline, your downline, whatever it might be. So I'm going to go in and I'm going to put that down to say a 275, and I'll hit apply on that. I'll then go back to my Cant graph. Now that we've got an allowable radius in here, there is no longer a red box around that portion. So then if I come down to this red portion down here, if you have a look down at the bottom of the panel just above where it says OK, apply, etc., it's telling me that my Cant rate of change is 1 in 1214.3, and it's less than the desired minimum. Over here we've got a unacceptable length. We've got an element length of 0 meters, and it's then telling me that the time to traverse that element is 0, which is less than the minimum amount, etc., etc. So in each of these little squares that have got the red line around them, we have got some form of deficiency or something that is outside the basis of design controls. So let's go and have a look now at how we can affect and change some of these things. Up the top here we have got a deficiency in this portion here. So what we can do there is we can go and change the speed of this particular curve and reduce the speed for that curve, and that should then alter our rate of Cant change. So we're going to go back over here to the main Cant design. We'll go and pick on the first element up here, And we can do this one of two ways. We can either go into the edit speed option here, which brings up a table for us, and we could say we want to go from 4,000 to the 4,102.655, which is the second line down here, and we can then change that speed to 50 there. We can say OK and update, recalc Cant. The other way we could have done it, of course, is that we could have just come straight into here, and on this side here we could have gone and changed it in there. It's a little bit more time consuming to do it that way, but either way is acceptable. It just depends which way you prefer to go. So if we now then come across here back to our Cant graph, we should then see that over here we've got an improvement. It's still not enough of an improvement, so it would then be a matter of going through and adjusting length of element or the speed for the curve, whatever it might be, to tweak that particular portion to make it match your basis of design. Now the next thing that we're going to look at is how we could go and add some virtual Cant in here. So if we come back to our Cant design, we can then come down and see that down here on rows, I think they're about 12 and 13, we've got a start and end chainage that are the same. So that obviously will give us a deficiency in there. So we're going to go and put in a virtual Cant in here. And what we're going to do there is we're going to go and pick on the first of the two chainages that are identical. I'm going to come across to the right hand side over here. I'm going to change that down from 64 down to 54. I'll update that one. Then I'll come down to the next line down here. I'll update that from 64 to a 74 and update that. That basically then has told me that I've now got a 20 meter distance through those portions in there. Now, does that fix it? Not necessarily. I'd still have to probably go through and tweak it a bit more, but we can now see that we are achieving a length of 20 meters in there. So again, it's just purely a matter of adjusting the setting, having a look at your basis of design, which will vary obviously from one individual track alignment to the next track alignment, and playing with it and so on and so forth. If we just go back up to the Cant design tab here, you can insert a line, delete a line, set it, delete all, whatever it is. There's also a rationalize button here. Now that was actually a carryover from earlier versions of 12D, when quite commonly you would get the start of arc, end of arc, and then it would put the next portion in as the start of the next element with the same chainage as the end of the previous element. So rationalizing it would actually dump all those duplicates out for you. 12D actually reads the data in much more cleanly now, so you're probably not going to actually use the rationalize button all that much. Okay, so let's now go and have a look at the Outputs tab. A couple of things on the Outputs tab that I want to look at. First of all, we can have three different types of outputs in here. We can put out a simple report, which we'll have a look at in a moment. We can do a CSV file, which we can then put into a Excel template, and we can do a Cant set out CSV simple by itself. So we're going to start off with coming into here. We can choose a stationary report, give it the interval we want to have through there, pick on the right button. As I've run this before, it's saying, do I want to amend this? I'll say yes. Of course, if you hadn't run it before, you wouldn't get that dialog box coming up. Now what it's done here is it's come up and said it can't run this because this MTF file doesn't exist. In actual fact, what's happening here is that under normal circumstances, we would come through here and say, right, one of two things will have happened. Either in a greenfield site where you are running this job the first few times, you may have already run an MTF through there and already have built up your formation and so on. That's your variable cost of bulk earthworks and so on will occur. So you may have already run this and you're not interested in running it against an MTF, which is what we're going to be doing here, in which case we then untick this option here. Now, if you are doing a reconstruct or realignment, something like that, then it may well be that you are actually using an MTF in the background and you want to take this Cant data that we're producing and apply that to your MTF, in which case you would need to have the MTF sitting in there. select that, tick that, and away it would go and add that to the MTF. So as I said, we're not using that at the moment. I've just unticked that. Come back in here, go and pick on the right and say, yes, I want to overwrite it. Stationing, do you want to overwrite? Yes. I can then come into here and open that report, and here it is in my notepad giving me my chainage, radius, level, speed, cant, etc. So that's the simple report format. Down here we can go and say, right, we're going to go and use a template for the spreadsheet, which we can go and pick up from our user or user library. This one that we're looking at here is the Cant editor, so I can go and select it from my library folder there. I can go and give it a file. Again, I've run this in the past, so it's going to ask me if I want to update it, but a different file name would get us around that. Do I want to save it? Yes, I do, and it exists, and it's processing down the bottom there. Say OK. Run that through, the report is done. It automatically opens Excel because I've used a spreadsheet in here. Now into this one here, I'm just going to have to go and pick on my browse button, go and choose my Cant data that I've just run in, go and pick on the read button here, and what that does is that goes and reads in my data and puts it into a nice spreadsheet format for me with a template that's already in there, nicely color coded and so on for you. The last one that we're going to use here then is going to be the cant setout.csv file. So again, we're going to pick on the right. The reason it's saying this is amended is because I haven't gone through and picked all the correct buttons. We'll just go and say yes, we want to apply it, run that through there, and then when we come in here and open this, there it is, coming in a slightly different layout from what we had before, just as a CSV without using a template file in the background. So we'll just have one quick last little look at these tabs and just run through what they do. Under the Cant design itself here, this is the geometry that exists in this particular alignment. The design limits, that is our global defaults, which as we've shown already we can go and override by putting in an alignment speed up here, Cant round off, the gauge, etc. If we wanted to go and change some of these, see in there we've got a minimum element length of 20 meters. That was why I went and did that virtual Cant and put it up to 20 meters. It was still failing slightly in there because my deficiencies in here were higher than what that would allow. On the Cant graph, that's where we got all of our information on there. Under the defaults here, you can actually go and put alignment speeds through different sections from chainage to chainage with a design speed in there, so it allows you to define a little bit more information on it. And we looked a moment ago at the outputs. As we said through here, if you were going to go and use the MTF option in applying this, you can give a rail to formation height, etc., adjust the hinge to low rail, a few settings in there. Most important ones down here are the names for the left and the right adjustments that we're going to make so that it knows how to go and put that Cant in onto your MTF. We're going to be looking at plotting the rails and sleepers, etc. So we'll get the option first of all from plot rails from the pull down menu, alternatively from the rail toolbar. We've got the plot rails icon over here, a little plotter icon with the rail underneath it. This is the panel that we have in here, so we're going to give this a function name. Now I'm just going to call this mainline plot rails. As we've discussed before, you'd probably have more detail than that in it in a real job, in that you'd say which particular line you are working on. So for mine, it's just going to be mainline plot rails. You go and pick the reference string by picking on the reference button here, select the super alignment. The interval, so we're going to put in here that we want to plot these rails at say 5 meter interval. When we come down to the height offset here, a couple of things could occur. As I normally design my line on the track center line with the levels for the top of low rail, I would have 0 height adjustment in here. But if you've designed on some other portion, maybe you've gone and designed on your formation rather than using the track center line top of low rail and using a hinge modifier to drop it down for the formation, then you'd obviously have to make an adjustment for the offset that you would need in there. You'll notice that when I pick the reference string, my start and end chainage have automatically been filled in for me. I'm going to come down here, I'm going to go and tick on the plot the rail profile. The name I'm going to put in here is going to be rails. The model that we're going to put it into, I'm just going to go up here and steal that name up here and put it down into there. Remembering you probably have more detail in reality. The color I'm going to go and choose here is to go and use the Viz Steel option, which is down here. If I decide to extrude the rail profile, which I'm going to do here, then what that's going to do is, instead of just giving me the string which is the top inner edge of the rail, which I will still get in this case anyway, when I tick that on, I can then go and choose a rail profile, and that will actually give that shape and extrude it along the line for me. So I'll end up with a string for the rail, but then I'll also have an extruded shape for the rail itself. We'll now move over onto the ballast tab, and on the ballast tab we're going to go and plot the ballast. In here I'll give it the name of ballast. That'll be the string name that's created. The sections model, I'm going to go and type cross sect and then put in my name of my line in there again. The strings model, I'm going to go str space control V again. Color for the ballast, I've got a Viz ballast color in here. There it is there. The rail to ballast height, in my case, so that is obviously the difference between the rail, the pantry plates, sleepers, etc. So in my case that happens to be minus 0.27, so 270 mils down. I'll give the width for the ballast to be 3.375, and I'll put a side slope of 1 in -2 on the edge there. Now in here I'm going to have to go in and choose a formation tin so that it can form that up. Now I created one earlier. If I go to my cross-section view here, you can actually see in here that I've got a shape in there which is my formation, and the capping layer in there which is a tri-mesh. So that all exists in a formation mainline tin. The one thing you'll notice when we look later on is that the slope of 1 and 2, although it's actually calculated, it won't create a tin of that portion for me. Cross onto the sleepers tab. Now what I normally say here is that unless you are absolutely determined that you have to have the sleepers all the way along the job, I don't recommend doing the plot sleepers, because what it does is it goes through and it produces every sleeper for the whole job, and it does mean that your graphics is going to slow down incredibly, and in some cases it's just not worth the hassle of doing that. Now if you want to see your sleepers and so on, then a better way to do it is when you actually run the job through, in the end you can go and use one of the visualization macros where we can place the rails and sleepers etc. along it. Across to the bore tunnel here. Now the bore tunnel option can be used to produce a superstring with a user-defined diameter and a vertical offset from the track. This produces a circular tunnel and would probably only be used if you were using a tunnel boring machine, because it's going to give you a totally circular tunnel. If you wished to have a tunnel of any other shape than circular, then probably the tunnel and structure tools from Design Tunnel Structures would be used instead of the tunnel boring machine which we're discussing here. Now I will go in and just put it in so we can see actually what it does for us. So I'll tick it on, I'll give it a name, I'll call it tunnel. I'll put it into a model of tunnel board, give it a color, I'll just go and choose something like magenta for it. the height above track, so that's the offset vertically for the center of it, so I'm going to go 2.5 meters there, and the diameter that I'll put in there will be 3.25. Obviously those are variables that would happen through there. And remember that modeling the formation, capping, drains, etc. would normally be done with apply many MTF, which I haven't done here, but I've read in that other tin and capping layer that I had there. So we'll now go and hit the recalc function here. That's gone through and run the job for us. We should now be able to go across to our perspective view. I've used a visualization in here to give me textures and colors in this. So we're going to add 3 new models into here now. So if I come into here, I will add my strings for the main line. So you can see there, these are the individual little strings that we've plotted. We'll see them in a cross section in a moment. We'll then go back into here. We'll add our cross sections for the mainline plot rail. So there are our 5-meter interval cross sections running along there, and then we'll go and add the mainline plot rails, and those are the extruded rails running down there. So we'll go and have a look at that now in a section view. Here's our cross section view. We'll go and add those same 3 models in. Just increase the size of this view a little bit so you can see exactly what's going on, and fit it to the view. We'll go first of all and add our strings in there, so our strings for the main line. You'll notice that because we've done the Cant option prior to plotting the rails, that they have taken the form of the formation plus applied the Cant to that as well. And then up here I'll go and add in the mainline plot rails, and you can see now that we have got those. There's our formation coming across there with for the ballast. Then we've got the rails themselves sitting in there showing us where they'll live. So the last thing to see in here then is probably if we come back here and we go down to our board tunnel, which I think was called tunnel board. There it is there. When we go and add that, you can see in here that we've now got this tunnel sitting there. As I said, it would only really be used in a situation where you're using a tunnel boring machine, but if you need it, it is there. Again, on our cross section, we'll go and add our tunnel, and there it is with our center up here 2.5 meters above. So that's the plotted rails portion. So just to finish off this session, you'll remember that we were talking earlier about creating the sleepers or not creating them, as in the normal method it would produce a very large file set that would take a long time to redraw, and I suggested that maybe using the visualization package might be the better way to go. So I've produced one ready to have a look at here, and you'll notice here that we have the sleepers and the rails and the ballast all in here. Now this of course does depend on you having the visualization package and being able to do extrudes, etc. The sky end here is a sky dome, and then we've got extrudes in for the ballast, but this allows me to zoom in and out as quickly or slowly as I want to, whereas if I had used the plotted rails option, then that would take a very long time each time I decided to do a zoom or a pan, or in a 3D view move around. Take a long time to regenerate that view. As in this session we're going to be looking at plotting structure gauge. First thing I'd like to point out is that as per the training notes themselves, there is a note and disclaimer that we must make certain you're aware of. The structure gauge panel is for rough calculations only, to give an indication of where clearance problems may occur. The panel does not allow for vehicle dynamics, suspension, etc., and the user should use a suitable clearance envelope package where critical calculations are required, such as calculating platform coping and tunnel clearances. So again, it is purely as a guide and a first look to see if you might be meeting your structure gauge clearances. So back inside 12D, what we'll be starting off with is we're going to read in a data set which will have the rolling stock dimensions, etc. In our training we're going to use a PDF of the rolling stock, Then we'll place an envelope of 150 millimeters nominal, whatever you decide is the clearance that you should consider safe, around the sides and top of the vehicle, and then we'll use that as a structure gauge. So we're going to come up here to File, Data Input, 2D PDF. The file we're going to go and read in is our rolling stock gauge PDF. From the source, we're going to go and just leave it pretty much as it is. Once we've selected the image, obviously, we're going to use. On the location tab, there are going to be no changes that we're going to make in there either. On the output tab, we're going to put in a stem name in here. I've pre-filled it in with rolling stock gauge raster. Obviously, whatever you decide to name it in there. We'll leave the raster DPI as 150. On the settings, we're not going to change anything in there. So we then come down to the create button down the bottom here, hit create, finish. We'll now go and see that in a new view. And we will see that we've got two models that have come in through here. One is the raster itself, so that is the PDF with all the white background. And then what we have as well is a model that has taken the vector elements out of that PDF. Now, of course, not all PDF documents do have vector information in them, but you'll see here that if I go and remove the raster image here and do a redraw, we've actually managed to pick out of this those elements that were in that data set as raster. Now, if you have extracted raster from it, that really means that the original image file is no longer needed, and that could then just be deleted, and we would work with this vectorized bit of data. To produce the structure gauge envelope correctly, we would need to position it with a coordinate of 0, 0 for the easting and northing at the center of the track, top of low rail. It's important to understand that if you set the origin incorrectly, in other words not exactly 0, 0, your structural gauge envelope will be placed in the wrong position all the way along the track. Similarly, we're going to scale this, which of course is factoring in 12D, down to the correct size for our job. And again, if the factoring is incorrect, you will get incorrect results. So you need to take time to get both of these steps correct. So we're going to start off by translating our data. We'll go to Utilities, H to Z, down to Translate. We want to translate our rolling stock raster model. We now want to calculate the amount of shift that's going to happen on here. So what I'm going to do is I'm going to come into the job here, and of course you can see that we've got the two rails sitting there, so the intersection of these two strings is the point we want to translate it by, and we want to put that down to 0, 0. So I'll come into here, I'll pick on the option here, come up and get my snaps intersection of picking with direction this string here, which is the top of rail, to this string here, which is the center line. So that's going to give me that point. I'm now going to go and toggle on my grid and put the grid snaps on. I'll then zoom out, come down here to find the 0, 0 point. That's now snapped to 0, 0 on the grid for me. That's given me my transformations through there. As per normal, we can use these options in the target area to move it to a model, copy it to a different model. I'm just going to go and use the replace existing. When I hit translate, you can see it's moved. Finish the panel, zoom into it, and we'll now see that 0, 0 is where we want it to be on the top of the tracks at the center line of the carriage. I'm now going to go up here and, while I think of it, switch off my grid snap. So I'm now going to go and factor this data. What I'm going to do is toggle my vertices on so I can see the portions that I want, and we can see here that I've got my edges of rail there, my center line there, and so on. And what we need to do is to check the distance from the inside of the left rail to the inside of the right rail. So we'll go and get our measure tool here, measure bearing and distance. We're going to go from this point here on the inside of that rail to this point here on the inside of this rail, and you can see that the dimension that we've got in there at the moment is 18.626. Now we need that to match our design gauge, which in this project is 1067 millimeters. So we're going to factor this data around the origin point of 0, 0. So we're going to go to Utilities, A to G, down to Factor. We want to factor the rolling stock gauge raster. The factor that we want to put in here is going to be 0.0573. So that is the wanted gauge of 1.067 divided by the 18.626. So we can test that out down here by going 1.067 divided by 18.626. Press enter. That gives us our same factor in there to a far higher number of decimal points. We'll just change that down to 3 there, and our factor of Z can stay as 1. The origin point here is going to be 0 for each of those, and we will replace the existing data, hit factor. Now what we'll do is we'll just go back in here and check the distance between those two edges of rail again, from the inner edge of the left rail to the inner edge of the right rail, and there is our gauge of 1.067. We can therefore finish our factor panel, close that down. We're now going to go and parallel that string and offset it by, in this case, 150 millimeters is what I'm using as a structural clearance gauge. You may decide on a particular job it needs to be bigger, whatever it might be. Whatever you decide, you'll do similar anyway. So we can go and parallel this string here one of two ways, either from our strings edit down to here to parallel, or alternatively we can come up and use the CAD option here to parallel it. Now when I go and choose the parallel, it's going to put it into a model called base, and it's going to go and put it in as a sine string. So again, you decide what you want to do and what models you're going to use. So I'm going to come in here, I'm going to pick from this point here, picking with direction up the string, because when I go and give it a positive value of 150, it's going to throw it on the outside, an offset height of 0, and you can see that it's gone and paralleled that string at 150 millimeters. Now what I've done in the meantime is I've gone and made a simplified or rationalized version of this. Again, to save time in the training here, I'm just going to go and switch that on. So if I come into here and find my structural gauge outline simplified, you can see what I've done there is I've just gone and trimmed out where it's looping back through itself and so on here, so I'm getting a better shape for that particular string. And that blue string is the one that we are going to use now for our gauge. So we're now going to go and use the actual structure gauge tool itself. We can get that tool from one of two places, either from the pull down menu under plot. There we have got the plot structure gauge. Alternatively, up on the track toolbar we've got the structure gauge panel there. The first thing we're going to do before we go and create a function or anything like that is we're actually going to go and write out our new shape as a structure gauge which we can pull back time and time again. I'm just going to tidy up my view here by removing the base model and the rolling gauge raster model. That then just leaves my simplified outline. So we're going to come across to the read write data tab. We're going to go and pick on the SG profile string, select our profile, load that from there, go and give this a name. We'll call that example passenger carriage, and we can now see in here that we have got our shape showing in there, which is our outline over here. I'm going to come down to here, I'm going to go and set that data back to the read write data over here. Got a few different things we can do. We've just used the option where we've loaded a structure from a string. We can actually plot a model to a string. We can read a structure gauge from a file. We can write a structure gauge from a file. We can read total vehicles from a file, and write total vehicles from the file. Now the vehicles themselves, as opposed to the structure gauge, the vehicle file would actually include the length of the carriage plus the distance between the bogies. So we'll be looking at that a little bit later on. We can come down here now and write a structure gauge to a file. So we'll just go and steal our name from back on this panel here. And we'll write a structural gauge to a file, go and give it the example passenger carriage. You'll notice that we can make that read only if we so wish, write that structure gauge out. We could then at any time come back in here to the read structure gauge from file. Once we've written it out, in a different job we could go and find the structure gauge file and read it in from that other job. So back over on the Create Edit Structure Gauge panel, a couple of things in here. We've got the view controls in here for the graph area. Those work similarly to the other controls that we've seen in these rail macros. In other words, slightly different from general 12D use. Also down the bottom here we've got an XY for each position created for the string. Now of course you could go through and produce a shape purely from XYs. That would be a fairly laborious way to go and produce it. Far better to read in a string in some form and then just develop it from that. So now we're going to go to the Create Edit Vehicle Data tab. So we'll come up in here. We're going to go and create a new vehicle. If we already had some, we could go and pick on the button over here and create them. I'm going to make a new one here, so I'm going to use my Control V again, which has got my name of my example passenger carriage in there. The next thing that I'm going to do is to go through and show you that on our original structure gauge, you'll remember we read this in, we then have the length of the carriage with the bogies. So we can now go and enter those lengths into the fields up here. So the bogie span is going to be 15.850. The vehicle length is going to be 21.000. And then for the structure gauge type, we can go and choose our example passenger carriage. We will now go and set that. What we've done is create the vehicle data that we spoke about earlier. Back on the Read Write tab over here, we can then go and write the vehicle gauge out again, make details read only, and then of course on any other job we would be able to go to the pop down list in here and go and read that file in to a different job. Now that the structure gauge profile has been created and all the details have been filled in, we can produce the function to send the structure gauge along the track. It's also important to remember that it's critical that you must have applied the cant to the superalignment before running the structure gauge function, otherwise the structure gauge will be placed flat without regard for the tilt of the vehicle due to the cant on the rails. Onto the plot structure gauge tab now. We'll go and give this a function. We'll call it SG main line. We'll come over to our alignment view over here. We'll go and select the reference string. We'll say that we want an interval through here of say every 5 meters. That'll plot the carriage's position every 5 meters along the track. Give the outputs a name, so we'll call this main line struct gauge. We'll give a vehicle model, so we're just going to go and steal that name from there and type vehicle on the end of it. We're going to have a section model, same thing again, sections, and the strings model, same again, strings. We have an option to store the calcs as attributes. Then there's also an option in here to use the greatest average of cant bogies. Now what that will do is give you the cant of each bogie and then average them out. So you can try both methods of using the greatest cant or not using the greatest cant, run the results and choose the best method to suit your particular need. So I'm going to go and create my strings. I'll go and make them a dark red. The start and end chainage have been inserted for me already as soon as I pick the reference string. We'll give this a height offset of 0. The reason for that is that we located and scaled our structure gauge to the correct position and size. If, for instance, your height to the rails was not quite right, you could make a height adjustment to rectify that. The vehicle type will go down, pick on the pop-down list, and we'll choose passenger carriage. We'll press on the recalc function. Of course, this is the first time we've run it, but the button says recalc function, and then we will have 3 new models. So let's go and have a look at those 3 new models. We come up to here, they all started with main, so I can use the trick of putting my cursor over the plus sign and typing the first letter, which is uppercase M. That brings up our 3 new models. I'm just going to add the cross sections in first of all, so you can now see there's cross sections every 5 meters along there. I'm then going to go and add the gauge strings. This will actually show us the vehicle itself, so that's the structure gauge that's been passed along it, and the main line structure gauge vehicle, you won't actually see terribly much on it. What that does is it gives us a short string for each pass of the vehicle and positions it accordingly. So that is where you'd get a difference coming in if you use the greatest of average cant bogies. As I said, up to you to go and check and see which way you prefer to go. Just remove the gauge vehicle again. We'll then go across and have a look at this in a perspective view. So into my standard perspective view here, I'll get this panel out the way. I can then go and do the same thing here, type my uppercase M, and I'm going to go and put on those 2 strings models again. There's my cross sections and my gauge strings running along there. So if I now just move out from here and so on, you can see what it's done. It's passed the shape of those vehicle structure gauge all the way along that string, and it's taking into account the cant, etc. as well. The last one that we're going to look at then is the cross section. Now there's a little bit of a trick to doing this. If I just go in here and get my cross section view showing and add my 2 strings in there and do a fit. In this case here, you can see that quite nicely what we've got is the cant showing that the vehicle is tilted slightly across. If I start then walking along that string, we sometimes get to a position like this where the shape of the structure gauge appears to be incorrect. Now in actual fact, there's nothing wrong with the structure gauge. It is the way it is presented along a cross section. So for instance, if you went back to your perspective view and went all the way along the perspective view, you'll see that there are no errors in the data. But what's actually happening is that this is an older method of developing the shape, and in a rewrite of the software, probably for version 14, we will have this going through as a tri-mesh shape, and the beauty of that will be that we'll then be able to also do clash detection on them. So just be aware that there's actually nothing wrong with the structure gauge here. It's only the way it's being presented in this cross section. And just to make things a little bit more interesting, I'm going to go and profile one of these sections, and you'll see that we have some weird things happening in here. This is purely because of the way it is developing the cross section as a shape, and this string is now the gauge at a particular chainage, so you don't want to actually profile the structure gauge string. What you need to do instead of that, to profile a string that runs along the alignment that is not part of the gauge, such as the ballast section, and then you'll get the shape of the structure gauge, although as I said, on some sections it may still appear incorrect. Again, notice the tilt of the vehicle outline here to take into account the cant on that particular bit of rail. What we might just do quickly now to finish this off is just go and have a look. If we go for a drive along this string, we should then be able to see that as we go around the different corners, it'll flick in and out with that particular cant. we can see we're coming into a right-hand bend here, and you can see the cant applying as we go around that corner, and it'll do that all the way along the chosen alignment, again provided you have applied the cant before running this process. Back to you now, Lisa. Thanks.
Thanks, Alistair. Now I think we've just got time for a couple of questions, so I'll just throw over here. So John in Perth has asked, can chainage equalities be used for roads as well as rail?
Yeah, they certainly can. I've seen them used for road jobs where they want to round a chainage off so that they might have multiple contractors on one single job, and so they can round the chainage off to suit around their contracts. Again, just be aware that what you're really doing is you're not changing the real chainage of the string. You're just basically tricking the display into showing a secondary chainage on that string. So yes, it can be used for road work, as an example.
Sure, okay, thanks. And Peter from Sydney has said, how accurate is the structure gauge tool?
Yeah, it's very accurate. There's one problem with it though. I think it was Peter, you said. Yes. What happens is that we are taking a static shape of our carriage and we're passing that along the railway line. We are allowing for the overhang on the nose and tail because we have our bogey sets set to the correct distance. So we're getting a good shape of that being set along the line, and we're tilting it with the cant on the tracks as well. The problem actually comes in that in reality your wagons or carriages have got a loose link between each carriage, and so that allows some sideways movement because of that linkage. We obviously have to have that so we don't crunch the rails around too much. And the second thing is that the carriages will normally have suspension on them as well. So you're getting extra movement in the carriages themselves, which our function doesn't take into account. But what we do is, if you think back to what I showed you, when we took the shape of the wagon or carriage from the PDF, we gave it an extra, in my case I allowed an extra 150 millimeters around it, and that was allowing a little safety factor to hopefully take into account that dynamic movement of the wagon. Now you would then have to say, well, is 150 millimeters enough? I don't know, that's one of those things. You'd have to look at your basis of design and see how you go from there, but there are some specific packages that are used that do take into account the dynamics. I'm not going to mention what they are here because they are proprietary software, which you just need to go and get your Google up and have a look and see what you wanted to do there. So hopefully that answers it for you.
Great. Thanks, Alistair. And thanks to our audience for your questions. Sorry to those we couldn't get to live today, but we'll be answering you by email. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next 2 training webinars will be Pavement Design for Construction on the 22nd of February and 12D Field Set Out on the 22nd of March. We've also got some great industry solutions topics kicking off from next week, so see our website for details of all of those. We'll also continue to keep you posted through email and social media. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.